I want to create amazing virtual worlds where we can talk and play together efficiently. In the age of AI, this shouldn't be a problem at all, except that it still is impossible. You see, when we try to render a virtual copy of the real world efficiently, it's not great. And breathing life into it by populating it with objects, not a chance. And it gets even worse when we try putting real-looking humans in it. Oh my goodness. I don't want to talk to this person. So this seems completely hopeless. So why is everyone talking about AI this, AI that, if it cannot pull this off? Well, to get the answer to that, all you have to do is look at these papers. Yes! Luckily, we have 3 amazing works that might solve all of these 3 problems. Let's start with this one. First, rendering worlds. In goes a bunch of images about the scene, but not everything. So, we need a technique to learn the scene and to be able to draw it from viewpoints we've never seen it from. That is really tough. It is kind of possible with NeRFs and Gaussian splatting, 2 of the go-to techniques to perform this these days. However, not so fast. If we don't have enough information, they can still introduce lots of noise and visual artifacts. And some of the results are just criminally bad. So, I don't think a single new paper could fix all of that, of course. So, let's see. Goodness, it can! These suddenly look almost perfect. Absolutely amazing. So, how is this even possible? What the heck happened here? Well, a genius idea happened. This AI technique is trained not to give us the perfect answer immediately, but to take an imperfect one and learn to clean it up. That is nearly as good as giving the perfect answer, however, it is much simpler to pull off. And when I look at the results with previous techniques, I'm thinking, I don't want to use any of these. And in just one paper, we go from that to, wow, let's start using this right now. So, worlds are working okay now. Great, but remember, that is just 1 out of 3. What if we want to put new things into this virtual world? Well, previous techniques are not great at reconstructing 3D information from a photo or a video of something. And this one was from just 3 years ago, and everything is so coarse here. I don't want to play in a world like that. Now, things have gotten a bit better since, for singular objects, newer AI methods can get pretty good results. But wait until you try an entire scene of objects. They completely fall apart. Even the better ones have trouble understanding object alignment and scale. Now, check this out. This one is from a different research lab. Wow! A new AI technique can do what none of the previous ones can do, and that is just take one image, not of an object, but of an entire scene, and create a digital 3D version of it. So let's go back to that alignment scene and see the new one. Wow! So cool! The whole scene with the correct scales and nothing is intersecting each other. So, how? Well, it has 2 incredible ideas to make this happen. One, it has been infused by a GPT-like AI model that is meant to understand the relation of these objects. And it is doing a glorious job at that. And now, let me show you the second one, my favorite. Look at this reconstruction. As we expected, positions and scales are correct in this scene. They are true to the input photos. That is excellent. But come on, man. The guitar is poking through the box. That is really difficult to guess correctly, but here is the second genius idea. You don't need to do that. The scene is generally good, but does not obey the laws of physics. Floating, poking things. So now, hold on to your papers, fellow scholars, and just run a simple correction step that is inspired by physics simulations and let it sort out all of these issues. Can it? Oh my! Look at that beauty! Fantastic! So, worlds and things are good. But the last puzzle piece, people, not so much. That is the grand challenge. Previous techniques are not great at creating digital versions of real humans. Do you want to talk to someone who looks like this? I think not. Unfortunately, this problem may be just too tough. Why? You see, we are wired to look at and understand each other's faces and gestures, so if something is off just by a tiny bit, the game is over. But it turns out there is a solution. Dear fellow scholars, this is 2-minute papers with Dr. Károly Zsolnai Fehér. Here is the new technique. Well, this is just so much better than the previous ones, I don't even know what to say. Let's look into the paper and see how they did it. Oh, yes. They take a bunch of deformable Gaussians, deformable little bumps, attach them cleverly onto the geometry of the face, and this can finally capture detailed facial motion, even up to 4K resolution. And you can throw at it some really strong gesturing, and all of those deformations are now present in your virtual version. So good. Now, not perfect. There are still some missing details. Also, the teeth and eye movements are not great yet. Also, there is still a little twitching going on too. But now, let's invoke the first law of papers, which says do not look at where we are. Look at where we will be 2 more papers down the line. So, near-perfect virtual worlds are in the works, and there is incredible progress on it. What a time to be alive! And once again, these are the papers that very few people are talking about. And I am worried that if we don't talk about them here on 2-minute papers, no one will know about them. If you appreciate that, subscribe and hit the bell icon, and you'll see a lot more stuff like this here. We need new tools for the era of LLMs, and Weights and Biases now has Weave, a lightweight toolkit to confidently iterate on LLM applications. Use traces to debug how data flows through each step of your app, and use evaluations to measure your progress. It is the best. Try it out now at wnb.me/papers or click the link in the description below.